Hi friends, this is the third video of this series. In this I am going to cover organic chemistry, which is from 33 question number 30 to question number 49. So this is the part 1 of organic chemistry. In this, let's take the first question. The Ayurvedic name of camphor is. So camphor, as you all know, is one of the most common chemicals that we are aware of and we use in day-to-day life. So this is a structure. For this, if we take the nomenclature, it is a bicyclic compound. So, and there are 3 substituents, 1, 2, 3. So just check out which are the possible ones. So if we take the standard nomenclature, we are going to get B as answer. For this, you have to understand what are the bicyclic nomenclature and how you have to give the naming. Similarly, there is a question as what is the IUPAC name of this compound. Here already given the numbering with 1 over here, 2, 3, 4 and 5. So according to this, one bromine as number 2 and another as 3. And the phenyl group is attached to first carbon. So while considering, there are 2 equation possibilities. One is 2,2-dibromo 1-phenyl pentane and other is 1-phenyl 2,3-dibromo-pentane. If you go to the answer key, you will get both C and D is correct. But if you go to the standard rules, only C is correct, where one of the rules states that if there are more than one substituent, then the name of the substituent is the way in which it should be arranged. If no prefix, like if you have one or more than one, means 2, 3, we take dia, tria. It should not be considered when you are considering the nomenclature. Here bromo starts with B and phenyl starts with P. So B comes first. So it will be 2,2-dibromo 1-phenyl pentane. But in case of answer key, they are given both C and D. Now next is identify the correct structure of bicyclo 2,2,2-octane. Means first what you have to consider is number of carbons present in the structure should be 8. Given a possible diagram, this is a diagram in which structure in which you get 2, 2, 2, 2, means where 2 refers to bridging. Here this 2 is a bridge, this 2 is a bridge and this 2. Total means there will be 6 carbons in bridging form and 2 will be connected. So this way we have to consider various structures in here. Starting from here, this is one of the and this is 2. Here they have 2, this completes one bridge. 1, 2 completes one bridge, 1, 2 completes one bridge. So here already we got A for the answer. If you consider other ones, here we get one bridge, single bridging, double bridge. So you have to consider the number of bridging and you have to identify it. You have to make sure that it is a single common atom for 3 bridges. Then it is considered 3. In case of the camphor one, you will have one single over here. That is 2 to 1. This side 2, this side 2, here we have 1. So this way you have to see. For bicyclic nomenclature, there are separate rules which you have to take care. Now let's go to the next question, where they are asked which of the following is achiral. Achiral refers to the ones in which you can superimpose on the mirror images. Means if you keep it this way and if you revert it and keep the mirror, you will get it this in the opposite way. If you have a right hand, you show as left hand, but you cannot keep, if you keep the left hand on right hand, it will not superimpose because the location of the thumb will change. Similarly, you have to consider in this. If you would keep the mirror aside and if you get the same figure, then we say it is achiral. In case of letter F, we cannot get because the structure will change. In case of letter P also will not get. Already I have given the example of hand, so it is for sure it is not going to be. Only option C, ball, because it is pure spherical. And those which are almost like what is a cube or uniform structures will give you a chiral compound. So the next question is, we have to find what is the major product in this reaction. This is an epoxide reaction and this gives a ring cleavage reaction. So these are the 2 possible products which we get. But here both the bulky groups are on the same side, so this is the minor product. But whereas in this case, it is a major product. So this option is option B over here. Now Among these, we have to find which are the aromatic compounds. For this, we have to consider Huckel's 4n plus 2 pi electron rule. So here, for the first one, we have only 2 pi electrons. One bond means 2 electrons. In this case, we have 4. In this case, we have 8. And this case will not arise because it is not closed at all. So automatically we can reject this. In this case, we have 6. So here in this part, being a open chain, I have shown why. So in case of 2, if you take the 4n, n should be a natural number. If it is a fraction, it is not possible. Here in this case, n will be 0. We satisfy Huckel rule. So option A is correct. Option 1, and the compound 1 is aromatic. When in case of second compound, it is 4, where you will get half. This is not possible. In case of third compound, it is already a open chain, so it is not possible. And in case of 4, it is 6 pi, that is, you will have 1. So option C is the correct answer. Now let's go to the next question. Here the question is, which of the following will easily undergo ionization? Now in this case, since we have already open chain, this is one of the easiest one. Now among the remaining 3, we have to find which is this. So this one is chloropenzene. As you all know, the bond between chloro and benzene has a partial double bond character. So cleavaging of this will be highly difficult. And in case of chlorocyclopentadiene, existence of pentadiene cation is not known till date and is considered highly unstable. Equivalently, does not exist in nature. So the only option remained is here. And this is since we know it's already aromatic, it gets stabilized due to constant resonance of this pi bond. So option 1 and 3 should be there. That is in option A. Now the reactive intermediate involved in carbylamine and Raymond-Timon reaction are. So carbylamine reaction is conversion of primary ammonia to isocyanate, and Raymond-Timon is conversion of phenyl group to salicylic group. For both, the common reactants are CHCl3 in presence of alcoholic KOH. Here also we have CHCl3 in presence of alcoholic KOH. Please remember one point, that if you have CHCl3, it will give a rise in presence of strong base, will give rise to carbene. So since both have the same reactant, so the only possible is both should be carbene. So the intermediate form is carbene, nor carbon anion nor nitrene. Now here we have to find the carbocation in the decreasing order stability. Means you have to give the first one which is the least, after that this, keeping on increasing. So when you observe, all three are tertiary, but the only difference is in each case the number of alkyl groups are increasing. As you all know, alkyl groups tend to give the electrons. So higher the alkyl groups will increase the stability. So this will have the least stability, whereas this will have comparable most, and this will have the most. So it should go in the sequence. 1 and 3 should be having less stability than 1, then 2, then 4. 3 should be having less stability, then followed by 1, 2 and 4. In other cases, you have to check what are the other groups added. Since all the groups are similar, it will not be an issue. But in case if there are different groups like NO2 or OH, then you have to consider which one is electron donating, withdrawing, inductive effect, mesomeric effect, resonance, and all those points. So now let's go to the next question. Here they are asked which is the strongest nucleophile present among this. So when you consider nucleophiles, you have to see if there is basic character in this. Presence of negative bond in negative charge indicates the basic nature, because they have already lost a hydrogen or proton and they are in depth, require of it. So in that case, even if they have another atom which can donate, they will give first priority to get to stable mode. So these two are basic in nature. As the basicity increases, nucleophilic character will decrease. So these two are weaker comparably. Now what remains is CH3NH2, CH2H5SH. Here which are the donor atoms is, in this case it is nitrogen and in this case it is sulfur. Now if you take the donor size of the atom, sulfur is having bigger size compared to nitrogen. So it is easy for sulfur to act as a nucleophile compared to nitrogen. So in this case the answer is A, C2H5SH. So now next question is SN1 reaction is favored by. For this you have to know what are the conditions for a reaction to proceed with SN1. Here they have mentioned unsaturation at alpha point. Unsaturation, if you have at alpha point, it indicates that it will SN1 means carbocation intermediate. If you have this, it destabilizes. So unsaturation alpha point will not be possible. Alpha branching will stabilize it, as we have seen in the previous question number 41, where the stability has increased with the increase in alkyl group. This is the carbon weight, so this is alpha. So this has stabilized it. So this question here, alpha branching will stabilize it, whereas in beta branching you will cause steric hindrance. Means when the incoming nucleophile tries to attack, it will cause steric hindrance. So this cannot be the possible. And since it is a cation based intermediate, non-polar will definitely not help you in this, because it will slower the rate. It will prevent the formation of cation, which is not favorable. Only option B favors the SN1 reaction. Now dehydration of this compound with acid exclusively use. Exclusively refers that only acid is present and nothing else. Now I have already shown the reaction along with the mechanism. So when here I have not considered any particular acid, I just shown a H plus. It will go to elimination of OH, forming H2O. Here we have a secondary carbocation. If we assume there is no change, there will be no alkyl shift. It will give this product. But this is not a stable one. So there is alkyl shift from this methyl group to this position, which will result in giving this carbocation, which is more stable compared to this, because here it's secondary, here it's converted to tertiary. And as we all know, more stability will be observed when it's more substituted, which will lead to formation of more product. So in this case, more substituted alkene is formed, where this hydrogen gets kicked out. Whereas if we assume the hydrogen over here gets kicked out, then it will be lesser substituted, which happens in lower cases. So the most substituted alkene is the major product, and here the option A is the correct answer. Now, so I'll take on to the next question. Here they asked us to name this reaction. So what I would like to suggest is, this is a direct question, but the issue is whenever we see this name reaction, none of them has been we say we are known. We might have studied them in different ways, in different other form. But when we consider this reaction, name reactions, directly we don't know what is the reaction. We may be doing in the reaction form, but the name, certain reaction is called with this particular name is not known. I would suggest you to go to different name reactions. For that, it will be easy to understand. So in this case, I have already checked it, and it is found to be Hoffman-Friedrichs reaction. So I will ask you to check through all these three reactions, and if you are unable to get it, then I'll post it in the next coming videos. So here, the reaction of acetaldehyde with excess formaldehyde in presence of NaOH results in this compound. So they are asking is what is the reactions possible in this entire stage. Please kindly remember that when they mention the excess of any reagent, single reactions will not be feasible. It will go to high number of reactions. So what are the reactions remain is cross Canizero and followed by Aldol, or else contains Aldol condensation with cross Canizero. Now before that, you have to understand what are Aldol and what are Canizero reaction. If you know this part about what is Canizero reaction, how does it take place, or what are Aldol reaction, how does it takes place, then it will be easy for you all to identify what is possible. If time permits, I will be taking the name reactions and explaining their mechanism in future videos. So here I've shown how it actually takes place. So initially we'll be having aldol reaction. Aldol means presence of aldehyde and alcoholic group. This reaction continues until all the hydrogens are substituted here. Initially they had 3, here it become 2, here it become 1, and the last one here. When this stage comes, it goes to Cannizzaro reaction, because there is no chances of formation of any enol, that is presence of double bond and alcohol. So it will go Cannizzaro reaction, which the last aldehyde group will be converted to alcohol group. So with this, it is consecutive aldol reactions followed by last cross Cannizzaro. Whenever you say Cannizzaro, there are two types, cross and normal. Normal means both the reactants belong to the same group, same aldehyde family. Whereas cross means there will be present of two aldehyde groups present. So with this, I'll go to the next question. Now here, conversion of 1,2-dibromo compound to alkyne will be achieved by. So when I say 1,2-dibromo to alkyne, means you have to directly get triple bond. Means both the bromines should be eliminated and you should get triple bond. So treating with aqueous alcohol, remember that if it is aqueous alcohol, it will never help in elimination, it will help in substitution. So it is going to result in diol. Fusion of KOH, okay, we can see about this later. Reaction with zinc powder. Whenever zinc powder means it is in pure zinc, it will react with both the bromines and give alkene. Treating with triethyl methane. Amine. Amine means NH2. Ammonia will be NH3. 3R3 means if all the 3 hydrogens are replaced by alkyl group, then you form triethylene. So if it is, since all the groups are substituted, the possible of reaction is not there. So only option remains is fusion with KOH. So initially KOH will remove one of the bromine, which will indirectly help in removal of the other bromine, which will give double bond, formation of triple bond. Now, so the next question is, toluene can be converted into benzaldehyde by oxidation with. Please remember that if you consider oxidation of alkyl group, it will directly convert to acids only, except for one reaction, particular reagent, that is dichlorochromium oxide. Remaining these three, if you check, will get benzoic acid, because it will not stop at aldehyde, it will further go to formation of acids. Now this question, identify the correct synthetic equivalent for the preparation of the following compound. This is the compound given. Here synthetic equivalent refers to a structural resemblance of a compound which actually gives the product. Means if we react to, suppose let's consider A and B, if these two are the reactants which give this particular product, then A dash and B are synthetic equivalent, which if in case when you do the reaction, when you are given the product, we don't expect to start knowing that A may be the possible one or B may be the possible compound. We assume for this it goes through a retrosynthesis process in which we break this compound and try to find out what are the possible reactants through which this compound has been synthesized. For this you have to go to retrosynthesis, where means retro means to come back, and on that we get A and B dash. So after that A and B dash, they are taken as multiple combination and checked out. So for one particular reagent will get this reactant form A and B, that is the original list. So this is based for our studies, and in this case option A is possible. I will not say these are not possible, but what happens is with this particular reagent, this may not be your, if this is A dash, this may not be B dash, it may be some other, so it may not give us the same product. Similarly with this, only in this case it is possible that we can get this kind of compound. So with this, I'll like to end my video. In case if you get any kind of doubts, you can please contact me. Please do like my video and share it among your friends. Thank you all.